Data visualization is an essential component of a data scientist skill set. And Seaborn is one of the most popular packages in Python to implement data visualization. Keeping the importance of Seaborn in mind, we have come up with this Seaborn Python tutorial. Now, before we go ahead with the session, I'd like to inform you guys that we have launched a completely free platform called the Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below.
Okay, so visualization, I think we briefly touched upon what is the purpose of visualization last time. Can someone quickly touch upon the scope of visualization, where we are, why we need visualization?
Easy representation of data.
Quite
Easy
easily.
understanding.
Yes, easy representation of the data that is out there.
To make sense of the data quite easily and to look at the patterns which.
Right. See, basically, two main points I think both of you covered on the things. Quickly, one is when you have a huge amount of data, it's not possible for you to go through each record that is out there and understand what the data is telling for you. And also you want to do an analysis, you won't have the overall behavior of the data. So when you visually observe some data, it makes a lot more sense. You'll try and observe patterns in the data, you try and observe anomalies, you try and observe outliers that are there in the data, and you see what is the basic distribution of data that is out there. That's the primary focus of visualization from an analytics standpoint. Then there is other purpose of visualization, which you present a data to business users so that they can understand and interpret easily than going to the complex analytics of the things. So the two objectives of visualization. So now where does this visualization come into play in the whole scheme of analysis? So let's quickly, we touched upon these things. Let me go on to the slide. We'll touch upon these things, but we'll go in detail about this. Yeah, right. So this is the whole scope of analysis. What happens right from you get a problem from your business to solve to when you come up with the final model. So in the process, if you look at, you have a problem that is given to you. You start looking at the problem and you define what exactly are you going to solve. It is sometimes imperative that the problem that is stated by the business is not exactly the problem that needs to be solved, because more often than not the business talks about symptoms and not the problem. So it is your responsibility to translate that business problem into an analytical problem. There is temperature, you go to the doctor does not treat for temperature. Symptoms, yes, he gives you paracetamol, but what is the underlying infection that is out there, how it is caused, and what is the antibiotic to be used is the doctor's responsibility. That's exactly the role of an analyst. You understand the problem, you convert that business problem into analytical problem, and based on that you start creating your hypothesis. Once you create your hypothesis, then you start looking at your data, what my data is telling to solve my hypothesis, and then you come up with visualization here essentially to see what my data is distribution, how it is looking like, what I can do on it. Then once you understand your data visually, then you get into exploratory data analysis. So exploratory data analysis and this visualization go hand in hand. Once you analyze all your data, you get your initial results and everything, then you get into creating a model. And once the model is done, you test your model, you feel that the model is working, and then you start applying it, and as the data comes in, you start tuning your model so that you get better results and optimized results. That's the flow of the exploratory data analysis comes into play. From that lens, there are four different terms that are used in the videos if you have seen. What are those four areas? You have your data or information, whichever way you call it. We'll look at what data versus information. But have you heard of these terms in the videos? Descriptive analytics, diagnostic analytics, predictive, and prescriptive?
Yeah.
What are these things, these terms? Descriptive, what does that mean?
It's describing what the data tells you.
Yes, it's exactly what is happening with the data. So you're getting a basic sense of the data. What is it telling you? That's all descriptive analytics does. So if you take an example, I'll go to the temperature example that I gave earlier. So if you go to the doctor sees that, okay, you are having temperature. For how long you have? It's for last 3 days. Are you feeling hungry? Is the temperature continuously there versus it is coming off and on kind of a thing? Are you feeling sick? Do you have vomitings? Do you have motions? He will check different parameters. It's data gathering, and he's analyzing data and collating it to come up with an aggregated information, to come up with some kind of a hypothesis to be formed. That's what descriptive analysis does. So we'll spend good amount of time on descriptive analytics today. Then diagnostics. Why did it happen? If you feel that you are vomiting, you have motions or something, then he gets into underlying causes. Why? Have you eaten food outside? Have you drunk water from a public tap or somewhere, or something that you ate food that is normally doesn't suit your body constitution? Something diagnostics would be done. Then you start predicting in what scenarios this is likely to happen. So in future, what you should avoid, doctor gives you kind of a prediction and making why it will happen, and he prescribes the medicines and the care that you need to take for yourself. Same goes for an analogy example in analytics, business problems, and anything. Is that point clear? I try to explain that through a very simple example, but the approach, the methodology that we take for applying for a business problem exactly lies into the same, so that we can connect with the terms. Does that resonate, folks?
Makes sense.
Yeah, yeah, makes
Yeah.
sense.
Great. So,
Ram,
yes.
quick question. How many hypotheses do we actually create, or rather, do we have multiple hypotheses for the same data set?
Brilliant question. Brilliant question. So, yes, you can have n number of hypotheses that you can form based on your data. Hypothesis is nothing but an articulation of business problem into an analytics problem. You are trying to solve a bigger problem. Let's say tomorrow your client, hypothetically I'm calling a retail firm, or one specific apparel firm like Vimal or Arvind Mill, something comes to you that my sales are going down. What should I do? I'm seeing for the last 4 quarters my sales are continuously dropping down. I need to understand the problem. That's the problem that is given to you. Now you start taking that problem, you will understand the data. Is it like overall sales going down? You won't do that way. Then you start understanding what are all the different arms that are there in that business. Is it like men's section, women's section, or kids section, or where are the sales dropping? Then you know that, okay, across the sections you are seeing drop. Okay, then the problem is not about the classification of the business unit. There could be something else. Is it by geography, particular geography causing it, or particular season causing it? What is causing exactly, where it is going? Then you start digging deeper and understanding. So you'll form sometimes based on your intuitive hypothesis can be formed on two things. One, once you do your exploratory data analysis, initial data patterns that are coming up, based on that you form a hypothesis. Or as a business intuition, your business knows a new competitor emerged, so you know a competitor is playing a role. Then your hypothesis could be different, or in some cases both could be a reason. You have a production related issues, you have a competitor coming into play, you have a market changes that are happening. Then you form three different hypotheses of the same data and you solve three things in three different ways. So you can form a number of hypotheses on your data. All right, so let's move on. So this is where the data comes in, and the next step, as we are talking about here, there are three stages of exploratory data analysis. One is univariate analysis, two is bivariate analysis, three is multivariate analysis. I'm assuming through the videos you would have gone through, I'm just skimming through and giving you clarity on the things. Univariate analysis is all about, you take one variable, like you take temperature, and anything you do is just about temperature. You do analysis on the data temperature collected over a period of time, and you do certain analysis on that one. It can be mean, it can be median, it can be trending patterns, ups, downs, whatever it is going. You do only one variable level analysis. Then two variables, when two variables have an interplay between them. So for example, when temperature is coming into play and water scarcity in a city, as the temperature goes up, water scarcity goes up. As the temperature goes down, water scarcity goes down. Is it just these two variables, how much they are connected with each other, how is one related to the other one, is a bivariate analysis. When I say multivariate, it's not about temperature and water availability in the city. There is a third dimension that is out there, which is, can someone think about what is the third dimension that can come into play? Rainfall. So rainfall is the other one. So despite having high temperatures, that area is known to get a lot of rain. So has the rains gone down? So now how is the interplay between your temperature, rains, and waterfall, or the rainfall coming in? So those three variables will play a multivariate analysis. You understand different dimensions. So this is the simplest of the examples. Once you get into your business problems, you'll start dealing with 1,000 variables, 2,000 variables, 3,000 variables. Then the interplay between all these variables really becomes complex. So this is all what we'll try and analyze in the process. Right, so just moving on. So there are three different libraries. We have seen Matplotlib, Seaborn, and Plotly that we touched upon last time. We'll go through a case study now. to see each of these things. Plotly we won't touch because it's primarily a web related stuff, more about dynamic visualizations and everything, slightly away. If you are interested, you can definitely touch upon. There's a complete library available. For the purpose of this session and these classes, we predominantly rely on matplotlib and Seaborn, which should be pretty good enough for us. Okay, so the syntax, we'll get into the case study and we'll solve that. Now the data. You have heard of these terms in the last week's videos as well as statistics videos. You would have seen these classifications. Two different types of data. Sorry. Yes. So there are two different types of data that we primarily look at. One is quantitative data. The other one is qualitative data. Your qualitative data is nothing but your categorical. Quantitative data is all about numeric. And again, each of these things will get divided into two types. Your categorical data can be two types: ordinal, scale, all these things. So what is nominal? Let's take small example of quickly what is nominal data looks like. Any example for nominal data?
Name.
Name, yes. But just name alone or anything else?
Car color, wherein you have a finite set of variables or
Right.
attributes.
So what is the purpose of a nominal variable? Why a nominal variable is used? It's purely for the purpose of identification, nothing else. So it's like an identification ID that you use. In a data set, you use a country name, it's for identification purpose. In a classroom, you use a person's name, it is for identifying that person, tracking his record, what he is doing. In a GDP, you perform how country's GDP is growing, what is the inflation, what is the WPI, whole price index, consumer price index, everything you're capturing against every country that is out there, country becomes a nominal variable. All you can do is reference rest of the data with that particular variable. It's that connection that is out there. That is the purpose of nominal variable.
So
But yes, sorry.
this can be used as an address if any.
Yeah, anything it is one single value is just for the purpose of identification. For example, if you talk of address.
Address.
Sorry, I missed the point. Can you come again?
Is this can be used as a address for that data stream? So
yes, yeah, exactly. Now I get it. It is like an address for that particular thing. So rest of all the data is referred by that variable that is out there. That's what when you mentioned address, I literally took the regular postal address that you're talking about. No, it's the address of the data. That's how it is. It can be considered. Absolutely makes sense. Right. So the second type of the data is
Boolean.
Or ordinal data. Boolean is one type. We'll come to that. But it's ordinal data. What does ordinal mean? There is an order in place. So let's say, for example, a telephone directory. Names are arranged in alphabetical order, but beyond alphabetical order for easier reference, does the order make any difference there? A phone number associated with a name is just a nominal data, but you just put it in an alphabetical order. It helps you in getting some sense. You arrange the data in alphabetical order, some order is coming into play, then it becomes ordinal data. That's all. There's no other things that you can do on a nominal data except for identification. You cannot do any other operation on that data. For ordinal data, you can arrange them in a order. It is like low, medium, high. It is like good, bad, ugly. You know the difference between the things, but you cannot do anything other than ordering them in a place. So if I know something is good than some other thing, can I know how much good it is? Unless you have a measure, unless you have a metric to calculate what is the quantifiable value of those good and bad, there is no way you can differentiate them. So that's what the ordinal data does. It just orders them in a particular way, but there is no way for you to distinguish how good it is or how bad it is or how ugly it is. That's what the ordinal data does. So your categorical data primarily handles those two types. Then your numerical data. We'll come back to that. When we touch statistics, again, we get those slides, we get these binary and symmetric binary, asymmetric binary. We'll touch on those things. This is primarily for the purpose of visualization. When you do visualization, there is a categorical data. You can combine nominal and ordinal together as one unit. And then you apply those labels for your numeric data. So now we'll jump onto numeric data. What does numeric data tell us? What kind of data is there in numeric data? Two types we are seeing here, discrete and continuous. What is the difference?
Continuous is changing with respect to time.
Discrete is a whole value. there is no parts or something in that particular process. Then in continuous, the data is like at an analog scale. You can think one as digital, one as analog kind of a thing. This is very basic and naive example, but one is digital, one is analog. Analog is like it's a continuous value, continuous thing. It goes on. Discrete is very unique value in that particular one. Based on the visualizations that you're trying to do, you can do two types of analysis. One is you can represent your data. You have numeric data, you represent it in some form. Some charts are more convenient to represent. You have some categorical data. Some charts are convenient and some charts cannot use categorical data at all. So we'll see which charts are convenient to represent what. So let's see, for example, you have a continuous data. You're taking here two variables, X variable and Y variable. You're using that. So now you have to combine X and Y and see how the Y is changing with X. You come up with something called as a scatter plot. You have seen a scatter plot, right? In the videos you would have gone through. So what does the scatter plot do? I was just trying to look for an image of that scatter plot. We don't have
a bunch of dots in Excel.
Right, fair point. Let me jump onto the statistic because I'm combining two sessions here. This is, for example, is a scatter plot for you. So every point represents a value of X and a value of Y for every individual or every record. For one record, you have two values, X and Y, and that is pointed here. So if there are n number of observations, there are n points which are scattered across in the plottable area. That's why it's called scatter plot. Clear? So the scatter plot primarily tells you the distribution of data in the surface, how the data is being distributed. So you'll get a sense of what the pattern is, what is happening in that particular one. So that's scatter plot. So box plot, has anyone seen what a box plot is? Yes. So what does the box plot represent? Yeah, it's a 5-point summary of your data. You have one variable. That variable you can have, and if it is a numeric variable, because it's a continuous variable, you can represent 5 different values. So what are the 5 different values that a box plot can give you? What is the minimum value? What is the maximum value? What is the first quartile? What is the median, or also called as the second quartile? And what is the third quartile? So the order would be like minimum, first quartile, median or second quartile, third quartile, and maximum. These 5 values are represented by a box plot. We'll look into box plot, how it looks like. And the same, let's say for example, your data temperature, as I said, you have temperature data continuously, which is a continuous variable. You can draw a box plot of it. But let's say I have temperature captured for 3 different cities. So if I break that box plot by a categorical variable, I can get it for 3 different box plots for 3 regions or 3 cities. That's why categorical variable comes into play. Beyond that, there is no application for categorical here. And when we say stack bar is more like a histogram kind of a thing. So it just represents one value and how much it is. That's all what stack bar can do. So for example, you see how many men have heart disease compared to women. So you can have 2 bars, one for men, one for women. Number of men having a heart disease, number of women having a heart disease. That's all stack bar can do. And if we want to combine all human beings together, one single bar, you can break that bar into 2 parts. Half of it is represented by men, and a different part of the other part of it is represented by females. So that's what is stacked bar. Stack is one over the other essentially. You can have 2 different bars versus in the same bar you can have 2 parts. Histogram. And how does a histogram work? What does a histogram tell us? Frequency. Perfect. It basically talks about the distribution of data. And you divide your data into different classes, or you have certain categories in your data. Each of the categories, what is the frequency? That's what a histogram plots at the end of the day. Facet grid, when we get into there, we'll create. Facet grid is about creating some grid or an image where you can have different plots plotted together, and you can use it for representation purposes. We'll get into facet grid when we touch on example in Seaborn. We'll do that. Right. So this is a box plot that we talked about. Minimum Q1, median Q3, and max. So here is a case study that we talked about. We quickly touched upon last time. Any questions, anyone, on the different types of charts? Once we see examples of those things, we get more questions and we get more clarity on the things. But if you have any questions, please ask me. Okay, this case study is all about honey production in United States at some point. So what they have realized is historically honey, US, which has been very self-sufficient in honey production and consumption, they started relying on honey, importing honey from other countries essentially. So then they started gathering the data historically, and they wanted to do an analysis of what is all causing that honey production, what are the reasons that are happening, what data we have, and what are the insights we can gather from that particular data. That's the exercise essentially. So the US used to locally produce honey over here. Now honey mostly comes from overseas, with 350 to 400 million pounds of honey consumed originating from imports primarily. So that's the extent it has. So the data that we have at this point is call a particular variable, which is number of honey producing colonies. If I have to just think about how honey is produced by honey bees which are in a hive. So many honeys get together and produce the honey. Those bees are called as working bees. So those are predominantly very important for producing honey. So this is number of honey producing colonies. How many colonies means it's a collection of bees is called as a colony. So how many honey producing colonies are there? What is the maximum number of colonies from which honey is taken during which year? So that's the thing. So one colony, how much honey it has produced during the year, that's the data is captured. What is the yield, honey yield per colony in pounds? Then total production of honey, which is multiplication of those two things, numcol and yield call. Then stocks refers to stocks held by honey producers. This is the number of stocks they produce they have in the market. This is a stock market type. So then price per LB, what is the rate of that honey being produced, and the production value of that particular one, which is again a multiplication of total production and price per LB here. Then some other information about states, categories, and everything. That's primarily the data. So the questions we want to understand is, how has honey produce yield changed from 1998 to 2012? One thing. They want to understand the patterns of honey production, changes happening over a period of time. Which states have produced most honey, which states have least honey, and which states have experienced most change? Can we come to that? It is about, now we talked about the exploratory data analysis earlier. So this, we are getting there. Now we're trying to break the data into some kind of a meaningful information where we can form our hypothesis. So then, does the data show any trends in terms of the number of honey producing colonies before 2006? Which was the concern over colony collapse disorder spread that happened. So basically there is a natural thing that happened, natural calamity or whatever you call the term. So that happened where the colony collapse disorder happened, because of which the honey producing bees, the colonies have started going down, and that has an impact in 2006. So what is the difference between pre-2006 and post-2006? Then are there any patterns that can be observed between total honey production and value production? How has the value of production, which in some sense could be tied to demand, changed every year? These are the 5 different questions they are asking for. We'll try and answer as many questions as we explore through the data. So given that I assume you have familiarity with the code, basic pandas and everything, I'm just quickly running through, but anyone has any question related to any syntax or why we are doing certain thing, please feel free to ask me a question. Are we good so far in terms of understanding what the case study is?
Yes.
One question is, why we put the percentage matplotlib inline? Does it mean to show the graphs inline?
I will explain that. We'll come to that. See, basically you import matplotlib every time. Just to quickly answer so that we close the question there. So let's say, for example, you have your graph. We say sns.pairplot. You put this. The moment you show this, a map gets created, but the map is not shown to us. You have to explicitly say that plt.show. Unless you say plt.show, the graph would not be displayed. You should type something like plt.show. Then the graph gets displayed. Otherwise, the graph will be in the memory. You have to type this. So every time you create a graph, the graph needs to be shown. Instead of that, you do matplotlib inline, this particular syntax that is out there at the beginning. This takes care of displaying that image automatically. You don't need to explicitly type plt.show every time. Is that clear?
Yeah, got it, Ram. Thank you.
Right. Thank you. So now we are importing pandas, numpy, seaborn, matplotlib. These are the 4 things that we need. Pandas is primarily for creating the data dictionary. Numpy is for doing some mathematical calculations as required. Seaborn and matplotlib are primarily the visualization tools, libraries that we use. So we're using, as usual, the read CSV function to read the CSV file that is out there, honey production. But anyways, once we go through that, we'll see all the variables here. So we saw my data head. It has, these are all the columns as we saw at the top. The state is there. See here, state, which variable? Now connecting the dots back, which variable is state? We discussed the types of variables earlier, data types and different types of variables.
It's nominal category, right?
Categorical or a nominal variable, basically. Yes, it's just for identification purpose to identify. Sorry, somebody has a question. So then numcol, this is a continuous variable. Then yield per call is again a continuous variable. We know total production is a multiplication of these two variables primarily. And then stocks, the worth that these people hold. Then price per LB of the production, how much production value and in which year. That's what the data that we have. So now I was talking about describe. Let me run this so that parallelly we need it, I can execute it. It gives the statistical summaries of all the numerical variables that is out in data. So in this variable, now we have numcol to year, everything is a numeric variable. If you look at this is not a numerical variable. That's why when you do describe gives does not include state, and it includes all the other variables, which is numerical variable. And when you do transpose, what happens? It just transposes the data display, nothing else. The count and these things comes horizontally and these variables comes this wise. But what if we want to see the state column also?
I think all you need to put in the codes, I think, right?
Yeah. So now I include state. Thanks for that. So if we include state, so how many unique states we have, that also you can get the sense. How many unique states you have, which is the top state, that is the maximum frequency occurring, and how many times it has occurred. That's all the data you can get about a nominal variable. So that none of these other things is possible as a numerical analysis. Whereas all other variables are numerical variables, and you can get all these kinds of data. And interestingly, for the numerical variables, it does not provide these unique top and frequency variables in this particular one. Is this looking clear? But just to see, for the year, it does all these calculations. It is calculating the mean year, which is nonsensical. It doesn't make sense of calculating the average year types. There is no standard deviation for the year, unless you convert the year into a different of a numerical form, which is more meaningful for you. So while it calculates, we might not get value for all. So we need to apply our judgment as to how do we apply that. The data types as we have seen here. So these are all numerical or float variables. This is an object. The info gives just that much. Now the question is, how many states are included in the data set? We have seen it here when we included state 44. You can get through this, or you can just say my data after the state variable, n unique. How many unique values are there? N unique gives you the unique values for that particular column. If I want to know how many times each state is appearing. So I know some states have appeared as high as 15, but I want to know it by state. Is there a way I can know?
Value counts?
Yes, absolutely. You're great. The value counts gives that. So NM, as we have seen there, appears 15 times, then LA 15, NY 15. All these states are appearing, majority of the states appearing 15, and NV is appearing 11. SC is the one that appeared only 3 times. That's a simple way of looking at it. So then which states that are included, which are the states that are included? The unique, N unique gives you the number of that particular one, then which state unique display of that particular states, this is the one. You can get all unique states that are there, just the unique value it gives. Now calculate the average production for each state across the years. So this is the simple question that looks, but sorry, I want to add one more column here, one more value here. So let's say, for example, you just want to calculate the average of production, total production. So my data, if I want to just calculate the mean of this one, I'll get the mean for that particular variable alone. But that gives me the whole. But the question for us essentially is to calculate the average production for each state. I need to do a group by for that one. I'm just trying to demonstrate it, how we came to this particular one simply. That's the mean for each of the states, mean or average for each of the states. Given that we are getting so many decimals, we don't want to do that. You use a round function, you just get this data. Is this clear how we are using that? Right. So then how many years data is provided in the data set, and what is the starting and ending of the year? So this is what we are getting. How many years of data? For the year column, you calculate n unique, you get the values 15 years worth of data is what we have. The lowest of the years, you calculate the mean value, you'll get max value, you'll get the maximum state. Which state has seen the highest volume of production? My data production, for the total production column, you can get the maximum value. You will get that particular one. So if you want to get all, you just use just this much, you'll get the value. You want to get the whole row, this is the syntax. You want to just apply this condition. So the total production value is equal to this particular one. For that, give all my data, it gives you the whole record for that particular one. Then average yield per colony, again you apply the same things. Instead of using just one variable, you can use two variables also to get the details, and you group by year there and get that particular data. Because you're grouping by year, you will include the year column into this particular one. Then the rest of the process, what you are doing for yield per call is exactly calculating average and rounding it. This is how you get it. So now the question, this is an important question. Is there a correlation between any two numeric variables? So how many numeric variables we have seen? 1, 2, 3, 4, 5, 6, 7 variables out of the 8 variables that are there. Is there a correlation between 8 numeric variables? So SNS is a Seaborn library, and it has a function called pair plot. Pair plot gives you as scattered plots of all the variables, one with every other variable that is out there in the data set. If you use pair plot of my data, essentially it more or less gives you the same thing, but the challenge that we see there is you have a state variable which is non-numeric, so it doesn't gel well. So that's why we exclude that variable and include all the remaining variables that are there in the data. So now what is the pair plot doing? So it's, if there are n variables, it produces a n by n grid. So every variable with other variable. So but if the first chart is numcol, and these are all the variables, and the same variables are listed in the horizontal this thing also. So there is no way you can do a scatter plot for the same variable. So instead of that, it is replaced with a histogram. So the data distribution of that particular variable that is shown in the diagonal, and all others a scatter plot is shown. So how do we interpret scatter plot? So this data distribution should give you some trend. If you just take this numcol variable with the yield per call, what is this telling us? Majority of the honey producing colonies have very low this thing. Only a few are scattered in the upper echelons. Otherwise, majority are concentrated just in this particular one. And what is the third variable? Total production. So production versus number of colonies. As the number of colonies increase, the production also increases. So this is pretty much a linear relationship that is out there, you can see. So now if you have heard of the correlation, anyway we have touched upon the correlation. We will touch upon correlation when we go into statistics, but now that you would have watched the videos already, I'm asking what is the correlation here? If somebody has a sense of it, you can answer. What is the correlation in this scenario?
The total production and number of colonies have a positive correlation, right? When they
positive correlation. So yes, positive correlation, right? But can we get a sense of what is the how much is the correlation value?
Closer to 1.
Closer to 1, absolutely, because this is pretty linear going along the diagonal. So if this is increasing, this is also increasing, this is increasing, this is also increasing. So except for a few points where even for the low value of this particular one to production, you get a higher number of colonies. This is a pretty linear relationship. That's what this graph does. But we'll talk about how to interpret the graphs a little later. So this is again another variable, numcol and production value. So the value of that particular one is also pretty much linear. And if you take this particular one, which is this variable, sorry, that is price per LB. So this is pretty much constant. Only for very few these things you have a higher value. Otherwise, it's more or less stagnated and concentrated in this region. It's only this much variation, but predominantly in this range. This is very, very acting differently into the things. Now, interestingly, for you, this whole pair plot that we are seeing is something kind of a symmetrical. Either you can take the upper triangle or lower triangle, because you see exactly the same graph here, but labels changed. Here it is numcol versus total production. Here this is total production versus numcol. So it's a mirror image, but exactly the same graph. So either you can focus on the lower half of the triangle or the upper half of the triangle. You don't need to look at all graphs to interpret the information because it's symmetry. Any questions on how do we get that correlation thing? Okay. we'll move forward. So this is a visual representation of this. Sorry, question.
Means shown there one concentrated one, that is second example which you have given. That yeah, this one.
This one.
Five. Next.
This one.
Yeah.
Okay. So let's look at that. Sorry.
This is like a pulse, right? Means it is a.
Your voice is breaking. I'm sorry.
You able to hear me? I will type it there.
Yeah, I can hear you now.
Okay. It's
No,
like
I can hear you now.
pulse or like a step input, like that the relation. Or
yes. So if you look at that particular one, the variation is appearing between this one to this one. So let's see what variable this is. Then we can start interpreting. This variable is price per LB. Okay. So we are looking at price per LB. How much price per LB is costing here? And this is about number of colonies. So irrespective of the number of colonies, as it goes up, majority is primarily concentrated in this zone. You can see my mouse movement here.
Yeah.
So majority is concentrated in this particular one. So till 20,000 number of colonies, the price is within this particular range, and just this much. After that, for very few colonies, essentially the price, as the number of colonies are increasing, there is a higher price coming in. There could be any number of factors that are influencing the price variation there. This thing. So fewer number of colonies are in this zone, and here, if as you move this side, what is happening? The price you are getting per LB is increasing. You are getting a pretty high price compared to this particular one, but there are not many in that zone. What does this tell me? So there are certain colonies which are getting a pretty high price, but those are far and few. There are not many. It could be because of the quality they produce, or it could be very rare in nature, or it could be those are the ones that are going to a high demand place where particularly people are looking for that particular type of the thing. Whatever the reasons could be, there are very few colonies that are getting pretty high price. Otherwise, more or less everything is concentrated in this zone. Not much variation is happening. Price because of the thing. That's the interpretation we'll get there. Does that make sense?
Yeah.
Right. Okay. So now the important part here is at this point, as I asked the question earlier, I think Prasad or someone answered. What is the correlation here essentially? Yes, it is a positive correlation. The correlation value is closer to 1 essentially. Visually, you can see on this particular one. But if I have to see exactly the correlation between each of these variables, what is the numerical value of the correlation that exists between these variables? I can just do a core function. I create a heat map. I can do a core or heat map, whatever I can do, and apply that particular. See here, I'm creating an additional separate data set with all these variables, and I'm calculating the correlation on this particular one and storing that in core, which is this table. So this is nothing but the correlation between the same set of variables that we have seen. Because a correlation with the same variable, numcol versus numcol, is always 1. So that's why you see the diagonal is always 1. And then again, the symmetry that I talked about, 0.243515, 0.243515, 953954, 953954. Here also you can look at the lower half or the upper half, essentially. Okay. Did you understand what I mentioned by core? So it is about this core is a function used to calculate correlation. It returns the correlation for a given set of variables. If you take 2 variables and do core, it just gives correlation for those 2 variables. Here I use 6 variables. It is giving correlation for 6 variables.
Ram, just
I'm
one
not hearing
question.
any nods. I'm taking that as you understood. But
Ram, one question here. Can you hear me?
Okay.
So as the value is closer to 1,
yes,
it
yes,
means
I can hear.
Okay. As the value is more closer to 1, does it mean it's strong?
Now, yes. If you see the correlation, good question. So let's come here. So if you take this numcol variable here, total production variable, what is the value we are seeing here?
0.95.
0.95. So yes, take that value for example, and take yield per call versus numcol. What is the correlation we are seeing?
0.24.
0.24. So let's look at both the graphs. So this and this is the same. This is 0.24 essentially. And what is the correlation here? We saw 0.95. So this is pretty linear in nature. It is going along the diagonal between the two things. So if the line goes exactly in this direction, diagonally, which means if this value increases, this increases. As this increases, this also increases. It is not like this is increasing but this is not going. So if you look at this particular one, this has gone up to only this much. The number of colonies are increasing significantly, but the production value is the production is not increasing. It's just this much. Whatever the variable I'm just using, price per LB column, it is only going this much. So this cannot be linear. So it has gone maybe linear to this part, but beyond that, there's nothing. It is only one directional. That is not growing. So the correlation in this particular one, you can see, for example, what is the correlation we are seeing? Minus 0.23. So anything that is closer to 0 means there is not much of a correlation, either positive or negative. We'll talk about what is positive or negative later, but that value is that much.
Okay, sure.
Hello, Chaitanya here.
Yes, Chaitanya.
Take the third, that is third and fifth example on the top. So here, if we convert into the equation, so it is like a y is equal to mx. Maybe c is not there. It's a straight line equation.
Yes, this is y equal to mx precisely because this is going through the origin. The c is not there. If let's say for example, let me see if there is another graph that talks about that. No, let's say for example another graph has come like this. From here at 20,000 the line goes. This whole points comes from here. What does that mean? There is a C component. Irrespective of whatever do, there is a basic element of production, basic number of colonies that are there, which is 20,000. So that's why that is intersecting the axis at this point. It goes to like this.
Yeah.
Then the C component comes into play. Otherwise, this is going to this one, y equal to mx. Yes, you are right.
And then fifth same row. That is y is equal to c, right? Means there is a, even if it is changing, or
yes. So there is a no x component actually does not have any bearing on y. Okay,
but
this is
how to find out that actually means this graph which is you are shown there is that the colorful graph down. The function is there, right? That is
yeah.
Yes.
That's a heat map, right? Yeah.
This is a heat map. How to get this heat map?
That how to find out the equation from this or
I think we are jumping way ahead about the equation part. We'll come to that probably in the next 1 or 2 sessions. We'll think about creating equations. What is the dependent? Then we need to understand a lot more things. What is a dependent variable? What is an independent variable? What impacts these variables? What exactly we need to look before we form an equation? We'll come to that. Definitely, I think because you asked that question about y equal to mx and going through the origin, I explained that. But just hold on for one more class, maybe we'll come to the concept of the variables and coming with equations.
Okay.
Right. So here we'll come back to this correlation, and in correlation, essentially we are looking at the values that are coming here. The same represents. So as you get a higher value, the color coding can be anything. There are different color patterns here. The C map is nothing but the color map. They are using a plasma. Then there are different color maps you can just explore. Go to this. There is a CMAP variable here. You can use different CMAPs that are possible that you can use. Matplotlib color plot object. You can search on Google. You find the different CMAP values available. You can apply any of them to get that value. But you can use, there are multiple color map codes that are available. The color patterns change essentially. You will see a different color patterns. Plasma is one example of that one. So minimum value is -1, maximum value is +1. Because for correlation, the value ranges between -1 to +1. That's why we have defined Vmin and Vmax values for this grid essentially. So this is the map essentially. So you see it starts from -1, goes till +1. -1 is completely dark, +1 is completely yellow. So that's how the color coding gets decided. So the CMAP and these values decide this line and color coding essentially. Is this part clear?
Yep. Yes, Ram.
Right. So the next one is point plot.
Ram, one question.
Yeah.
So
yes.
This heat map is used not specific to correlation, is it? So when you said -1 to +1, so it can be used,
not specific to, it can be used other ways also. It can be used other ways also. So, but predominantly this is used here because a correlation map makes us easy to understand visually what are the things that are really correlated with each other versus not. That's why we use. But heat map can be used in different contexts. Let's say, for example, you take 100 states that are there, and on different parameters, you want to see. Just give in Excel, you see, right? For example, let me go to Excel simply. Let's say, for example, this value. I select this value. I do a conditional formatting, and maybe I give this. This is also color coding in a way. So you can do this kind of color coding also using that heat map variable essentially.
Okay, got it. Thanks.
Got it? So it can be used for any purpose. Correlation is the example or the instance I'm using here, but you can use in different contexts.
Okay.
So moving on to point plot. A point plot essentially is about for each of the variables that are here that you list in this point plot. Here, for example, we are taking the total production and we want total production by year. That's what we are trying to do. So this draws a line essentially. This is for each of the years. What is the total production happened? You see. So if you see this graph, for 1 second, ignore the vertical lines that are out there. What does that tell you? We'll come to that. So if you take this vertical plots, what is the interpretation we are getting in? The total production over a period of time is going down. That's what the hypothesis that we have seen. And that's the same interpretation we are coming here. But now why these lines? What does this tell you? So each of these line, the point plot, sorry?
I think it's a range, correct?
Yes, it is a range. So what is the range that is coming here? What is the minimum value that is out there and maximum value? So this tells the whole value, but the total range that is out there is given by this particular one in that particular year. That's the variation you get. Clear? That's what the point plot gives as an additional value. So even though value is decreasing, 2010 seems to be an exception. The production has been phenomenally high in that particular one, which is reflected by a small bump there. So this gives you a much deeper view than just a point plot and a trending line showing the drop in the production over a period of time. That's one way to know the things. Now the last question. How is the production trending for each state? We'll just take the production variable again. So here I talked about facet grid, right? Facet grid helps you create this grid structure. I can define how many graphs I need to create in one row, which is column wrap. These are the columns. So the column wrap I defined at 10 and size is 3 by 3. This is the size is a 3 by 3 grid, each map size. That's how it defines. If I change that, now the grid size changes. It has become even smaller. It is getting different values. If I say only 5 columns per column, it creates a different way. 1, 2, 3, 4, 5. It creates five columns only. So you can just play around and see which works. Given the number of data you are looking at, which column you are looking at, how much you want to do, you can start exploring. But what this does, it plots. This is basically a context setting. This facet grid does not do any kind of mapping. How your map should look like is defined by facet grid. You understand that part, right? So here I want 5 columns and size of each graph is 5. That's what I am defining. And the base it should be based on my data set. I defined that. Now that is assigned to this variable called G. Now through that G, I am mapping a plot between year and total production. So the year is on this x-axis, total production is on my y-axis. So I know per year what is the thing that is coming up, and the marker is dot, which is nothing but these dots that you are seeing here. The marker is this particular one. The plt.plot is showing. So the plt.plot that we are used is the plot created here. We are plotting that here, passing that to G, which will put that into this facet grid that we created. The data gets mapped into this particular one. So now it's about interpreting this data. See, some of these variables for the state AL, there is no change. It has been the same. Maybe marginal drop, it is looking the same. Here it is slightly up, here down. But this state, California, seems to be an interesting one. It is overall, if you look at the trend line, it is dropping. It has dropped, marginally gone up, then continuously dropped for 2 years, then gone up. Then there is a significant drop, significant up, then continuously dropped. But overall, if you look at the trend line, it is dropping. So you know based on this information, that this graph, that California is acting very differently. Then similarly, Florida is acting very differently. But most of the states are more or less showing the same trends. These are the quick observations. And this state is interesting. San Diego, you are seeing an upward trend actually. Even though ups and downs are happening, you can see a marginally upward trend line on this particular one, which is an interesting state to look at. So once you identify this, somebody asked about creating multiple hypotheses. Maybe I create a separate hypothesis as to why North Dakota is acting differently, or why a San Diego, is it San Diego only? Why California or Florida, or these are acting differently compared to those. You create separate hypotheses for them, and then you can do deep dive analysis accordingly. That's how you can use these graphs for your purpose. Does that make sense?
Yes, sir. Yeah.
Yep.
Yes.
Good. So now we are getting into something called as a LM plot. LM plot is predominantly a scatter plot. The advantage that it gives you is the trend line that I talked about. If I create a trend line for this one, this chart for North Dakota, it is slightly going upwards. If I create the same trend line for California, it is a declining trend. So the same graph you can create here using the numcol and production value, two different variables taken. But for numcol, if you draw a scatter plot for this one, it creates, just to use a scatter plot, it creates a scatter plot for this. But what does this LM plot does? It creates a trend line for this. You know how much is, where is the trend happening. So now can you see this small blue shade happening around that line?
Yeah, exactly. Yeah, right.
So what is that shade indicating for me? Any guesses?
It's the range of the trend line.
Range of the trend line, but more importantly that you don't see that same the shade dispersion at the beginning of the thing. You are seeing it is increasing
Right.
only when you're going on the other end, because the data is linear mostly here and more concentrated in this part. As you go to the things, the data is getting distributed. The shade distribution is also happening accordingly.
And the correlation is going down as the graph is moving up, right?
Yes, because it's not like a completely diagonal 45 degrees. It is more at 35 degrees or 40 degrees, somewhere around that one. It's not a 45 degree. And the dispersion is happening more in the data as it is going on the higher values. The same thing is reflected by this shade at that here. That's what LM plot can tell you when you look at the data. The syntax is, once you share this file, you can use the syntax and start exploring for different variables and look at that. Now, in the interest of time, this is another version of the LM plot, but you're breaking it by hue. Hue gives you a variable, use a categorical variable where you can get the distribution for all the categories in that particular variable. If I take state has some 15-20 states listed, or 30-40 states, whatever it is. For each of the things, the distribution is shown. While the map is confusing, it's a demonstration. You can get a sense of how the overall distribution is coming up for all the states together, the trend lines. That's what it shows. So again, LM plot by year, same thing. Now this is a box plot. So what does the box plot say? As we have seen earlier, minimum value here at the bottom. This box, lower part of the box, this talks about first quartile. The line inside the box talks about median. This line talks about third quartile, and this talks about the maximum value. That's what the box plot tells us. That's what we interpreted, right? But now you see a lot of dots here. I know Abhinandan talked about these dots in the video. Does anyone remember what these dots indicate?
Outliers.
Yes, they are the outliers. But my question is, if you have a maximum value here, how come there is a value which is an outlier above the maximum value?
I think maximum value is calculated based on that 1.5 into IQR.
IQR, yes, right. That is calculated using 1.5 into IQR. For those people who are not in sync with that IQR concept, I'll come and then we talk about it. So basically, when this box plot is created, it takes all the value into cognizance. Then it defines the acceptable range of minus 1.5 to plus 1.5 of the IQR value. IQR is nothing but Q3 minus Q1. This is third quartile minus first quartile is called as the IQR. And you take that IQR value and multiply that by 1.5 on the minus side and on the plus side of these things. Then you get your minimum maximum values decided. And then whatever the values lying above that higher value of 1.5 IQR that you are getting in, those will be identified as outliers. That's why you see all these outliers across. And this happens more so when you plot all of these things together. Let's see how this box plot is getting created. So we are creating a figure and axis. Axis is primarily for this grid that is creating. So the size of this plot size basically 20 by 10. So we're using 20 values and 10 columns types. And then box plot for between year and total production. So this is the total production that is plotted by each of the years. The data is pulled from my data set. And when you create that, the box plot is created through this one and it is pushed into this figure. Figure is nothing but about creating this box where all values can be put together. That's what the box plot explains. And for each of the years, if you do for just one variable, you can do just for one variable, you'll get just one graph. But this gives you a comparative view of different categories for the same value. So now I want to look at total production. I can do this box plot for just total production alone, which gives me one single box plot. But I want to see comparatively how across the years this total production is varying and how does the box plot look like. And this is how I do it. This gives you a comparative picture essentially. Now, again, this is another example of point plot. The question is value and production changes over years. How does the point plot works here? Essentially, it goes on this. Then LM plot we have seen.
This brings us to the end of this Seaborn Python tutorial. Now, before you guys sign off, I'd like to inform you that we have launched a completely free learning platform called the Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. So guys, thank you very much for attending the session and have a great learning ahead.